This is section 4.7, and we've got some more equations and some inequalities. And let's look at solving a rational equation, and that's where you have two rational expressions, one or more rational expression. So you want to get rid of these denominators, and you figure out what's the LCD, what's the lowest common denominator that both of those will go into. Well, in this case, it's x squared. So you multiply x squared by each of the terms in the equation. When you do that, well, here you can see those cancel out. Here x goes into x squared, leaves an x, and then we have 1x squared. So what happens, now we have 6 minus 5x equals x squared, and we don't have fractions, and we all love that. So let's move everything to one side so that we have it equaling 0. If we have a quadratic, we want to do that. So we'll subtract 6 and we'll add 5x. So we've got this. We want to think about what are the things that multiply to give us 6 but could add up to add or subtract to give us 5. Well, either of these might work, but we've got to get a 5 in the middle. And so we need one positive, one negative. The only thing that's going to work is the 6 and the 1. So we have an x plus 6 and an x minus 1, which means x is negative 6 and x is 1. So that's how we would solve that. Just get rid of you find your LCD and get rid of the denominators. Now, solving polynomial inequalities. Let's look at this chart here. So here is an equation, negative x to the fourth plus 5x squared plus 4 equals 0. And that's the graph of that, and the solution are the places that it hits the x-axis. But if we're solving that same thing greater than 0, it's the graph that's above. So we have from negative 2 to negative 1, u, because we have a break, and then we have from 1 to 2. That would be the solution for that because it's an interval. If we were solving for that expression less than 0, that's below the x-axis. And so we've got this piece, which is negative infinity up to negative 2, and then negative 1 all the way to 1, and then 3 to infinity. I mean 2, sorry, I was looking at the 3, 2 to infinity. So your solution sets for inequalities will be intervals. Your solutions for equations will be simply 1, 2, or 3 solutions, however many x-intercepts there are. All right, I've got some steps to solving rational inequalities. If you will follow those, it should work fine. We're not going to do this on the calculator. We're going to do this by hand. So we're going to find the solutions of the top and the bottom. We're going to draw a number line and use those solutions to separate. We'll define the intervals. We'll pick a test value in each interval and determine the sign, and we'll write the solution. Now, you don't have to necessarily memorize those, but we need to understand how they work. So let's go through one and see what happens. So this is the original problem. 2 minus x over 2x is greater than 0. So we're going to solve the top, meaning take this and set it equal to 0. We get x is 2. Take this, set it equal to 0, and we get x is equal to 0. So that is that first step there. Find the solutions of the top and the bottom. We've done that. The second part says draw a number line. So you're going to draw a long line, and however many of these you had, you draw those hash lines, and you put them in order. X equals 0, then x equals 2. So we've done step 2. Number 3, define the intervals. That means, what is this whole space in here? And remember, you always have negative infinity here. You have positive infinity here. So this interval is from negative infinity up to 0. This interval is 0 to 2, and this one is 2 to infinity. So we have defined the intervals. Number 4, pick a test value inside the interval. So that means a number that's in here. Now, you could pick negative 532.8. That's a number in that interval. But we're going to be plugging it in, so we want to make it as easy on us, on ourselves, as we can do. The easiest thing I like to do is maybe go one number beyond the barrier. So negative 1 here, 1 here, 3 here. Now that doesn't mean you have to pick the values I do, just something in the interval. Determine the sign. That means we're going to use this part, this thing here, and we're going to plug in our test values and see what we get. So if I plug in negative 1, I end up with 3 over negative 2. That's a negative. We don't care what the number is, we care about the sign. Here we get a positive 1/2, so that interval is positive. Here when we do it, we get negative 1 over 6, and we're again negative. So those are our signs for our intervals. Now it says write the solution. Our problem was to find where is this thing greater than 0. That means where is it positive? There was only one solution, 0 to 2. If it had been where is it less than, we'd have had this one and this one. So that's how we'll do the rational inequalities. All right, let's go look at our problems for 4.7. All right, number 1, find all the real solutions of the following. So it may look a little daunting, but these are really pretty easy because we're going to multiply both sides by this x plus 6. When you do it over here, it cancels out. When you do it over here, it gets multiplied by 0. So you're essentially multiplying this thing over and getting rid of it. So you have x plus 2. That's not right. Okay, I am not sure what happened there, why that was that way. I think that got copied wrong, but that should, I have corrected it on my end. It is not coming up here. Try something else. Okay, I think we've got that corrected. It was just copied down wrong from the top to the bottom. So x minus 2 equals 0, x is 2, and there is your solution. Let's go to number 2. Find all the real solutions. Again, we're going to multiply y plus 3 to the other side, but in this case, it doesn't go away. We've got a 3. If we multiply 3 by that, we end up with 3y plus 9. But now we don't have a fraction, so that's nice. We got 7y minus 63 equals 3y plus 9. We're going to subtract 3y here. That leaves us 4y. We're going to add 63 here. That gives us 72. We'll divide by 4. We've got y equals 18. And you'll note there's these things that say extraneous solution. We haven't had one of those, and we're going to wait till we do, and then we'll talk about that. But we have a solution, y equals 18. Number 3, we're going to multiply the x squared plus 3 over here. And we are doing it to both sides. I'm just not writing that, but when you do, it cancels out here. And so we've got x cubed minus 9x equals 0. Factor out an x, and that leaves you x squared minus 9. So here you have one solution of x equals 0, and you have two solutions here. When you factor that, you get x is 3, x is negative 3. So you list all three solutions here. We don't have an extraneous yet. All right, let's look at number 4. Number 4, we did one something like this in the lecture notes, but we needed an LCD, and our LCD here is x squared. So we're going to move down here where we have some room to work. We're going to multiply x squared all three terms. When you do, this one cancels out, it leaves 77. X goes into x squared, so this becomes x, and then we have 15x squared. So what that did by multiplying by the LCD was to get rid of all the fractions. So we've got this now. We want to turn this into a quadratic equaling 0. So we'll do that. We'll get the negative 77 over here. So you want to think about what multiplies to give you 77. but we've got to add up to 34, and we also have to consider this 15, so this one isn't as easy. So if we think about 7 and 11, that's the factors of 77. 15 could be 5 and 3, so it's really a guess and check. So if you put 5x here and 3x here, we need one of each, and we need a negative 34. If I have a negative 11 here, that's negative 55 plus 21. That does give me negative 34. So you want to check yourself on that. Then you take each of those, set them equal to 0. We're going to get two fractions. So 5x plus 7 is 0. 5x equals negative 7. X equals negative 7/5. 3x equals 11. X is 11 over 3. So now the other way, if you were struggling with factoring, you could put this thing in y1 in your calculator and 0 in y2 and find the x-intercepts of it by second calc 5, enter. You would get these numbers. They would be decimals. You could turn them into fractions. All right, let's do this one. Now this one's a little different because it's a proportion. We have fraction equals fraction. And so the easiest way to do that is to cross multiply. Multiply here, multiply here. So we have x plus 4 times x minus 7 equals x plus 3 times x minus 8. Do the FOIL on both of those, and you get x squared minus 3x minus 28. Remember, FOIL is first, outer, inner, and last. Over here we get x squared minus 5x minus 24. So now we just want to combine and get to where we can solve this. So if I subtract x squared over here, those are gone. Then if I add 5x, that leaves me 2x. If I add 28 over here, I've got 4. Divide by 2, x is equal to 2. So A, and the solution is 2. Number 6. Now, this is where we're going to run into an extraneous. So let's look at this one. Our LCD, well, first thing, I would factor this because you don't know what things will go into it. So if you factor this, you get x minus 8 and x minus 7. So you have one of those here and one of those here. So the common denominator is these two multiplied together. So down here, it takes a little room. I'm going to multiply each piece by our common denominator. So I've got it written like that. The LCD is that. Well, here, x minus 7 cancels with that, but leaves x minus 8. The x minus 8 cancels and leaves 7 times x minus 7. Here, they both cancel and leave negative 1. So now we're down to this. We have no fractions. That's awesome. X minus 8 minus 7 times x minus 7 equals negative 1. Distribute this minus 7, and you have minus 7x plus 49, because minus times minus. So then we're going to combine 7x, a negative 7x, and a positive x gives me negative 6x. And then I've got 49 minus 8, that's 41, equals negative 1. Subtract that 41, so now I have 6x, negative 6x equals negative 42. Divide, and I get x is 7. Now, let's look at our original. If I put 7 in for this x, it's undefined. So that can't be a real solution. We did all our work and we came up with that. So there's not a real solution. So you'll choose C. There are no real solutions, but an extraneous solution of 7. You get that when it all work, you do all your work, you come up with an answer, but when you do the check, it doesn't check. So it's not that you did anything wrong, it's just an extraneous solution. So that's that. All right, number 7. Solve the equation and the inequalities. So we've got a picture over here, and I highlighted this with above in this gold and below with this green and the actual x-intercepts for red. So A says, where is it equal to 0? That's the red dots, -4, 2, and 4. Where is it greater than 0? That's the gold parts. That's here from -4 to -2, and then from 4 to infinity. It's all about the x. We're not going up, really. We're talking about the x values. Where is it less than? That's -infinity up here to -4, and then -2 to 4. And so that's how we're reading those. We got another one in number 8, and I highlighted it as well. Above is yellow or gold, and then below is green, and the red is where it's equal to. So where is it equal to 0? That's -4, 1, and 6. You can just see that on the graph. Where is it greater than? We've got -infinity up to -4, and then we've got -4 to 1. Where is it below? We've got 1 to 6, and then 6 to infinity. Okay. All right. Where is this undefined? Identify where f of x is undefined or f of x is equal to 0. So we don't hit anything. We don't have a f of x equals 0. But where is it undefined? It's undefined at x equals 2. Where is it greater than 0? From -infinity, that negative kind of got squinched up there, but from -infinity to 2, and then 2 to infinity. I'll try to fix that. All right, that looks a little bit better. And then select where is this less than 0. It is never below the x-axis, so it's never less than 0. All right, 10. Solve this symbolically. And we can do that symbolically, but I like to do these also on the calculator. So we have this, and I put that in the calculator and got this graph so you can see it real quickly. You've got -2, 0, and 2 as x-intercepts. Where is this greater than or equal to 0? It's from here, from -2 to 0 in brackets, because we got the equals, or from 2 in bracket to infinity. So I find that doing it on the calculator is really just a great way to solve that. All right, let's do this one. Solve this one. Solve symbolically. Where is this less than 0? If we put this in the calculator, we're going to get this picture, and we're talking about below, and that's -4 to 2, 2 to 4. Number 12. We're doing the same thing here. We can put this, I'm showing you how you could find those x-intercepts real quick, but we could do it in the calculator, and we're talking about where is it less than. So if we've got -3, 0, 3, from -3 to 0, and then from 0 to 3, it's all under, and it's all parentheses because we don't have an equal. Number 13, you put that one in, and you get your x-intercepts. You've got 8 and 9 and 10 right together. And where is it greater than or equal to? Well, from 8 to 9 with brackets, and then from 10 with a bracket to infinity. All right, 14. Where is this thing? What I would do is move the make the 60x squared go over here, and we're finding the solution set for this. So when you graph that, where is this less than or equal to 0? Okay, this is x equals -6. This is x equals 5. It's all the way between both of those. So it's going to have brackets, -6 to 5. 15. And 15, I think, is our last one. So it says solve this graphically, which we've been doing. We move the negative 84 over, and you put that in your calculator. It gives you the windows here, and I would suggest using those windows. This is the y-min is 2, the y-max is 14, scale of 2. X-min, negative 10, 10, and a scale of 1. When you do that, you can find that x equals 2 and x equals 6 and 7. And where is it below? It's from negative infinity to 2, with 2 having a bracket, and then between 6 and 7, both in brackets. So I think that will get you going on 4.7, rational equations and then polynomial inequalities.